This is General Physics 2, Week 10, Lecture Part 9. What I'd like to do is talk about how to use a transformer so that we can connect a 12-volt bulb to 120 volts AC. How can we do that? So say we've got a 12-volt bulb that's meant to be plugged into maybe your car, to use the 12 volts in your car, and now we'd like to be able to hook that up to household current that's 120 volts AC. That 12-volt bulb is probably intended for 12 volts DC. And so the first question is, okay, if we're going to try to use a transformer, that's going to take AC, 120 volts AC, and it's going to produce some kind of voltage AC here. If this is a 12-volt DC bulb, what voltage AC should we apply to it so that you get the same 10 watts of brightness if it's a 10-watt bulb? Well, that is a question we talked about before, and the answer is 12 volts AC. 12 volts AC, 12 volts RMS is exactly the right value to get the same power out of this thing as 12 volts DC. So what we want is 12 volts AC here. Even if it's meant for DC, we're going to apply 12 volts AC and it'll work just fine. So what kind of a transformer do we need? We're going to hook it up, and we'd like to have a transformer. Here's the symbol for a transformer. A couple of coils like this, and then a couple of lines. These two lines are just symbolizing the core, the iron core. So this is going to be our circuit. The only question is what sort of transformer we're going to look for. We want to have 120 volts AC coming in, 12 volts AC coming out. In other words, we want the voltage to step down a factor of 10. And the way you do that is have the coils be kind of like I've drawn them, but even more extreme. You want a 10 to 1 ratio in the coils. The turns ratio in the coils would have to be 10 to 1 so that it would drop the voltage by 10. So that's the kind of a transformer that we need. What about the currents? How much current will flow in the primary, and how much current will flow in the secondary? That's the next question to answer. Well, the current in the secondary is going to depend on this part right here. We know it's 12 volts, and we know it's 10 watts, and then we want to figure out the current. So we want a relationship between power and voltage and current. And that's just that power, the average power, is the RMS current times the RMS voltage. This is the RMS voltage, and 10 watts is the average power. So 10 watts is IRMS times 12 volts. So IRMS is equal to 10 divided by 12, and that is 0.83 amps. So that's the answer to that. The I2 here is 0.83. Now, what about the current in the primary? And here you just have to remember that the ratio of the currents is just the other way around from the ratio of the voltages. So where the voltage is high here and stepped down to a low value here by a factor of 10, currents are the other way around when you have a high current here and a low current on this side. So I1 would be 1/10 of I2. And so that would just be 0.083